Hello, today we have a stadium problem. We are gonna um, place that stadium in a triangular region. So we are gonna find the best place. We have two options. The first option says the same distance from three cities. Um, Second option, which is equidistant from existing three highways. But first of all, we have to construct a triangle. So we first I try to construct a segment with a given length. So which is the first one is 11.1. Okay, I'm gonna change the name later. And for this, I'm gonna use this circle and radius, and the radius is gonna be 32.2. It is too big, but I'm gonna use the zoom out option, and the same thing I'm gonna use for 28.5. So for this one, 28.5, and now I'm gonna use this intersection or that one, but I'm gonna use this one for to make the figure similar to the original. Let's make this point. Click C in the line segment from A to C and from C to P. That is my triangle, and let's see the distance of the zone: 32.2, 11.1, and 28.5. Now I'm gonna hide this two circle. This is my triangle, and let me move up, and let's make this distance more visible, and let's move to the middle, and we can make like, so I cannot move that. Okay, what about B? Okay, it's pretty good. Okay, the name of the city is A is Chapel Hill, so I click and let's make it C, but the capital one. Sorry, capital one, and this is gonna be um, Durham. Let's make it just D, and this is gonna be Raleigh. Make it letter R on the capital letter. Okay, we construct a triangle, and the first option says the same distance from each three cities. We are gonna use circumcenter. So finding the circumcenter, we are gonna use perpendicular bisector for each side. So I'm gonna use this one. Okay, and perpendicular bisector of this one. If I use this one at that point, let's make it A. Okay, I'm gonna hide the rest. This one, this one, and this one. So let's check this. A can move this side. Okay, so A is circumcenter. I can draw the circle and we see. We don't need to draw, but let's make it more visual. Yeah, this is our circle. Okay, I'm gonna hide this point B. Okay, let's check the distance from, this is circumcenter, from A to D, A to C, and E to R. So let's see whether the distance is correct. 16.31, 16.31, and 16.31, as you see, we made it. Okay, let's make it, this is 16.31, and this is the 16.31. Okay, for this, place for this center, this circumcenter, we should build new highways. So I'm gonna calculate here. A is, as you see, A is the circumcenter. I'm gonna calculate AC plus AD plus AR. So let me type here AC plus AD plus AR. Let's make it parenthesis. And from here, I think there's a problem. That is not C1. Let's make it C. Why it is? I think there's a point which is hidden. Yeah, that one. So let's delete this one and let's go back and change this to just C. Okay. Now let's make the calculation again. AC plus AD plus AR, as you see, is total 48.3 miles, and multiplied by constructing new roads is $125,000. So as you see, is $6,116,531. This is the first option. Let's type it somewhere here. So the second option says equidistant from existing three highways. So I'm gonna hide these line segments. I can hide the circle too, and I hide this A. If I need, I go back and check them. Okay. For the second option, I'm gonna use the in-center. So finding the in-center, let's go and check this angle bisector of each angles. So I find this one. This is the first angle bisector. For D, I did it, and for R, we did it. Okay. So let's locate the point. This point is E. Now I'm gonna hide this angle bisector. This is my center. So I'm gonna go back and draw a circle. Yeah, this is my center. And let's make it. Yeah, I think this is the perfect one. I have to delete this F. Okay, it says equidistant from the existing three highway. So I'm gonna draw line segment from A to, no, first let me make some points. This, I think, and this one. So let's join E to G, E to H, and E to I, and let's find the distance. We did good. 4.39, 4.36, 35. So I think there's some problems here. This points. Let's go back and let's find the perpendicular line from this point to this. So let me see, get the points wrong. Let's delete or hide these points. That is my point. Is gonna be this. Okay, and the other one is from this point here. Yes, this might be the point, and the other one is going to be okay. Now let's give the name of this. Okay, now I'm gonna hide this. Sorry, I'm gonna hide this one, that classify the straight line segments from E to L, E to J, and let's find the length. Okay, the distance now, I think 4.3, 4.3, and 4.3, and this is also 4.31. It's not visible, but let's prove yes. Okay, this is my in-center, and let's calculate the total cost. Okay, this is let's make a parenthesis, EL plus EJ plus EK times 125,000, because we are constructing new roads, highways, plus we are going to resurface the rest of the highways. So let's say parenthesis RC plus RD and plus DC. So DC. And we're going to multiply this one by $50,000 per mile. Yes. As you see, it is 5,207,800. So we have the answer for two options. The first one is 6 million, slightly more than 6 million, and the other is 5 million. And this second option is less than the first one. So the question says, for each option, describe how you use the DGE to determine a location for the stadium. Include a screenshot that shows the three cities and a proposed location for the stadium. Also, for each option, compute the cost for road construction and resurfacing. So we did these things. We made a calculation. And question 6 is, which option would you choose? Explain. Of course, the cheapest is the best. So we are going to choose the second option, which is $5,202,500. Okay,